Everyone, and welcome to the lecture on logistic regression. So we'll approach logistic regression in the following manner. We'll start by exploring our dataset and do some visualization. Then we'll train and create a logistic regression model, and we'll evaluate our model. We'll look at precision, F1 score, recall, and then we'll see less features and try to build another logistic regression model. We'll be looking at a dataset from University of California. And if you want to read more about logistic regression, you can see the documentation that scikit-learn has. Okay? You can read more about it there. Okay, back to our Jupyter notebook. As usual, we start by importing the libraries that we need. Import pandas as PD, import numpy as np, seaborn as sns, matplotlib as plt, and then we have the magic function to see our graphs on Jupyter notebook. I just copied this from one of the previous lectures. Okay, and this is the location of the dataset we'll look at from University of California. So we'll start by loading this dataset. So we can use pandas read CSV method, pd.read_CSV, and then we'll pass the URL, and I'll save this in a variable called data. Okay, run it. Now let's see what the dataset looks like by calling the head method. So this dataset is a dataset for students' admittance based on GRE, GPA, and the school's rank. So we'll approach this from a logistic regression perspective, and admittance will be our target. So based on these features, GRE, GPA, and rank, a student will be either admitted or not. So admittance has a value of either 0 or 1. 0 means not admitted, 1 means the student is admitted, and this is the GRE score. GPA is the student's GPA, and rank is the school's rank. So for rank, we have 4 ranks, 1 through 4, and that will be the school's rank. Okay, so based on these features, these 3 features, we'll try to build a model and see if we can predict admittance, either 0 or 1. Okay, so let's call the tail method to see how many datasets that we have. So we have about 400 records. So more about our dataset, we can call the info method to get an overall idea about our dataset. So we have 400 columns, 400 rows, GRE, GPA, rank. So they all are integers, they all are numbers, right? Integers or floats. And then the size is 12.6 KB, so not so big. Okay, let's see some statistics about our dataset. For that, we can call the describe method, data.describe, and this will give us some statistics about our dataset. We have a count of 400, mean value. For instance, the mean GPA of our dataset is almost 3.4. We have standard deviation, and so on. Great. Next, let's do some data visualization and see what we can get from visualization. Okay, let's start by plotting a histogram of our GPA, for instance. So we can call the hist method that matplotlib has, plt.histogram, and then pass our GPA. We can index GPA from our data frame. So GPA, make sure to pass the exact spelling. Okay, so we have our GPA, then we can specify some number of bins, let's say 35, and I like the color blue. Let's also add some labels for our x-axis by calling the xLabel method, plt.xLabel, and then we'll pass GPA. Okay, let's see. So this is what it looks like. We have GPAs ranging from about 2.3 to 4.0, and we have the number of students on our y-axis. So you see here at 4.0 we have the highest number of students with a GPA of 4.0, whereas most of the GPA lies in this area between 3.1 and 3.6. So that would be the average GPA, and that's what we saw earlier. The mean GPA is about 3.4, and you can make your plot bigger by calling the figure method and then pass the fig size attribute. You can set it to be, let's say, 10 by 6. That fits well for my Jupyter notebook. For you, this figure might be a bit different. So here we call the hist method that matplotlib has. You can also just call the hist method on your data frame column. So we're trying to see the GPA column, right? The GPA of students. So we could have also called the hist method on it and then pass the number of bins we want to see, color, let's say blue, and then we can add labels by calling the xLabel method for our x-axis, and then simply say GPA and run it. You get the same figure. This is just to let you know that there's also another option. Next, let's see a histogram of our GRE scores. Okay, so I'll call the hist method and then index our GRE column, number of bins, let's say 35, and then let's use the green color. Okay, let's label our x-axis by calling the xLabel method and then pass the name you want, GRE score, and let's run this. So this is what the GRE score looks like. The lowest is about 230-ish, and the highest one, it looks like 800, whereas most of the GRE score, the mean of the GRE score, lies somewhere here between 500 and 700. And if we look at the admittance column, we'll see admittance as either 0 or 1, right? Those are the only two options for admittance. Let me see the column name. So if we try to see a histogram of our admittance, we'll see that we don't even need the number of bins. I'll just pass color, let's say blue. So this is what it looks like, either 0 or 1. And we see that most students are not admitted, right? So that's just to show you. We either have the value 0 or 1. Doesn't matter how many bins that you put, because the values are only 2. Okay, next let's see the rank column. We know that the rank column has the values either 1, 2, 3, or 4. So the maximum number of bins we'll have is 4. So to show you that, let's index our rank column and then call the hist method on it. So for color, let's use red. You can pass number of bins, it's optional, but it won't make any difference because you'll only get 4 bins, 1 for each rank. And from here we see that the most common rank is 2, so that's the school's rank. 2 is common, and then 3, then we have 4 followed by 1. We can also try to see the relationship between two of our columns. For instance, we can see the relationship between, let's say, GPA and GRE by using a joint plot. So to do that, we'll call Seaborn's joint plot method. So sns.jointplot, and then pass your x and y for our x-axis. Let's pass GPA, and for our y-axis, let's pass GRE scores. Okay, and our data comes from our data frame, and let's pass a color blue. Okay, and if we want to see a KDE plot, we can pass KDE for the kind attribute or parameter. Okay, let's run this. Joint plots. I am missing a T here. Let's run this again. Okay, here is a joint plot of your GPA versus GRE. Okay, here we see that our Pearson R value is 0.38. So there is some correlation, not a strong one. Remember, the maximum value for this is 1.0. So there is some correlation, not too much, right? So this visualization helps us to see any relationship that our features have. Okay, and we could have also plotted our joint plot without the KDE. So let's remove that so that we only have scatter plots and histograms. So that's what it looks like, GPA versus GRE. So this data visualization techniques give you an overall idea about your dataset to see if they are related to each other and so on. So it's a very common technique before you build up your regression model. And in the next lecture, we'll continue our discussion on logistic regression. Thank you, everyone.